All right, and I just started recording, so this call from this point forward will be recorded. Okay, so this problem is referring to two sections in chapter 6. Part A is a question from section 6.2 and part B is a question from 6.4. And this is definitely something similar to what you will absolutely be seeing on the exam. So a boat capsized and sank in a lake based on the assumption of a mean weight of 144 pounds. The boat was rated to carry 70 passengers. After the boat sank, the assumed mean weight for similar boats was changed from 144 to 174. Okay, so for part A, assume that a similar boat is loaded with 70 passengers and assume that the weights of people are normally distributed with a mean of 181.5 and a standard deviation of 39.5. So before reading any further than that, you know this is a normal distribution problem. Let me bring in a graph that we could use so it'll be neater than anything I could draw by hand. But this is what you should be drawing by hand, physically drawing by hand with paper and pencil before you do anything on Excel. Let's see. All right, so we're given that the weights of people, use this, the weights of people are normally distributed with a mean of 181.5 and a standard deviation of 39.8. Okay, so you draw the graph of the normal distribution. The mean is the center, so 181. Why isn't it working? Oh, there we go, 181.5. Standard deviation is given in the problem as 39.8. So this is what your work should look like so far on your paper. Now, part A, find the probability that a boat is overloaded because the 70 passengers have a mean weight greater than 144. Okay, so here's 144. So find the probability that the boat is overloaded because the 70 passengers have a mean weight greater than 144. So greater than means area to the right. And we're not looking at X values here. We're looking at X bar values. X bar is the sample mean. And we have 70 passengers. So N equals 70. And we want to know the probability they have a mean weight greater than 144. So we're looking for the probability that X bar is greater than 144. And so this probability is equal to this area. All right, but anytime you're looking for probability related to a sample mean, And this is something you should write down on your sheet of notes that you're going to be using for the test. Anytime you have a normal distribution problem dealing with the probability of a sample mean, you must use a z-score because you're not given any x values. You can't use x values because you're not given a specific x value in the problem. You're given this sample mean. So this 181.5 is your population mean. This 144, that's your sample mean. Okay, so you have to, there's no other method. You have to use a z-score. So we have to take that graph and convert it to a z-score graph. I mean, it's going to look the same. You're still looking for this area. But instead of these given values for the means, we have to convert those to z-scores. So standard normal distribution, which means we have to take this value of 144 and convert it to a z-score. And the way we do that is with our formula, z equals x bar minus mu divided by sigma over the square root of n. And all four of these numbers are given in the problem. X bar is 144, mu is 181.5, sigma is 39.8, and n, the sample size, is 70. So all this given information needs to be plugged into that z-score formula. All right, so that's the first thing. Before we could answer the question, we need that z-score. So let's do that in here. Okay, so I'll just type that formula into Excel, equal x bar 144 minus the mean, which is 181.5. That's the numerator. And then divide that by standard deviation, which is 39.8 over square root SQRT of 70. Okay, so this is what I have written in blue to the left, just typed into Excel. So that will convert our normal distribution into a standard normal distribution. Okay, so now I could get rid of that question mark, and that z-score is negative 7.88. All right, this is the only way to do these problems. Every single one you have to convert. When I say every single one of these probabilities of a sample mean, if you're talking about the probability of a sample mean, you have to convert that given value of x bar. So in this case, x bar was given as 144, and you have to convert that to a z-score, which in this case is negative 7.88. Now that will allow us to solve the problem. Remember, the answer to the problem is this red area. That's the answer we're looking for. That's the probability That's the probability that X bar is greater than 144. And to find area, we have the Excel function for that. Equal norm dot S, always a dot S if you're using z-scores, dot dist parentheses z-score comma 1. So that will give us always in Excel, it's the area below something. That Excel only gives us area to the left. So if you want area to the right, it's 1 minus the area to the left. And that. So this first answer was the z-score. The second one, the probability that X bar is greater than 144 is equal to, and we'll use Excel for that, equal 1 minus norm.s.dist. So the 1 minus is making it to the right of the z-score instead of to the left of the z-score. And our z-score is right here, so I'll just click on that. Or you could type in the number negative 7.88, either way, comma 1. And the reason that Excel gives us an answer of 1 is because it's technically, I mean, it's very, very close to 1. It's like 0.999999, maybe 15 nines, which is not exactly 1, but when you round it to 3 decimal places or 4 decimal places, yeah, the directions say round to 4 decimal places, you get 1. And I think if we if we show enough, it's actually, this is the exact answer, 0.9999999999998. So that's the exact answer, but Excel is saying, or the problem on my math lab is saying, okay, round up to 4 decimal places. So that rounds up to 1. So in section 6.1 and 6.2, you saw problems like this. The probability that X is less than some number, the probability that X is greater than some number, or the probability that X is between two numbers. Okay, so in those situations, you could use X values or Z scores. It's up to you. My advice has been, every time we bring this up, my advice has been, if the original problem uses X values, use X values. Norm.s.dist. Or if you want to change to Z scores, you use the formula Z equals X minus the mean divided by the standard deviation, and then the Excel function equal norm.s. dot dist. So that would be z comma 1. This would be x comma mu comma sigma comma 1. Right. So for these types of problems, the probability that a single object is above, below, or between two numbers, you could use x values, or you could use, oh, nope, sorry. This is wrong right here. I put a dot s in there. I shouldn't have done that. I was thinking dot s. It was on my mind, I guess, from the problem we just did. Equal norm dot dist. If you use z-scores, that's when there's a dot s. Okay, then in section 6.4, you saw probability problems, like the probability that the sample mean is less than some number, the probability that the sample mean is greater than some number, or probability that the sample mean is between two numbers. When you have a sample, a normal distribution probability problem, where you're talking about a group, in the problem we just did was a group of 70 people. You must use a z-score. So you have to first get the z-score using the formula x bar minus the mean divided by sigma over the square root of n. So these four numbers that you plug in, all four of those numbers are always given to you in the problem. And then you'll use the Excel function norm dot s dot dst z-score that you find up here, comma 1. This z-score is that one. All right, so just again, if you have a probability problem with a sample mean, that means you don't have one single x value, so you can't use x values. You only have a sample statistic. Okay. Any questions about that explanation? All right. What's next? Hey, please don't, when you're preparing for the test, please don't just focus on what we've done recently, because this is only a small part of the test. You have 4 sections from chapter 4. You have also 2 sections from chapter 5 as well. All right. Does anyone else, anyone on the call, does anyone have any more questions for me while I'm on?
Thank you for that. How can I have access to the recording?
It takes the better part of a day to process, and I'll get an email once it's ready to view. And as soon as I get that email, I'll upload it to YouTube and send an email to everyone in the class with a link to the video.
Okay.
I'll also post it where I posted it last time. So on my ePortfolio under Zoom meetings, the last Friday, this is where we started talking about the exam and about the projects. So I'll email a link, and I'll also post a link in red right here next to this meeting once I have that, once it's processed. Okay, if there's no other questions, we could go ahead and end the call. Today and Sunday, I will be mostly unavailable. I may have a little bit of time tomorrow. Just it's tough with the holiday weekend and a couple of kids at home. But if you do have questions, please send them my way. Otherwise, good luck preparing for the test. And like I said in the last couple of review videos or the review calls, make sure you spend a good amount of time, not just a few minutes, but I mean, hour, 2 hours, 3 hours, however long it takes you. In addition to working through problems, the test is open notes. So whatever materials you could gather and create before you take the test, the less likely you are to run into situations where you don't know what to do. So, you have all of my notes, all of my PowerPoint notes. You have all of my Excel activities, not just the videos, but you have every single thing I do on Excel. You have access to my solutions, so you could, click on any box, any cell, and you could see what I typed in, what function I used. All that stuff is there for you to use as a resource. So my advice is spend some time putting together like a nice set of notes for the exam. All right, everyone, enjoy the rest of the holiday weekend and good luck on the upcoming test.
Thank you.
You're welcome.
Thank you, Professor.
Thank you.